Right, and here we go. Today is day 2 of quadratics, so we're going to use it to review pretty much everything that we have learned to this point. Do you remember when we would have a quadratic that was upside down and you have these things? What are those things called? Oh, pausing for a second. These are the roots, the solutions, the x-intercepts, and the zeros. Okay, good. And there's a way to get them that works every single time. Even if they're imaginary. What's the way that gets the roots every time? It's also what you feed baby quadratics. Quadratic formula, very nice. Okay, the quadratic formula is the way that would work every single time. Could you also often graph it and see where it touches? Sure. Okay, then the only other way I can think of is if you can factor it, you should. So then there's last option here is this point is a really important one, and that's called the vertex, and there's a formula for that. X equals that? Yes, x equals negative b over 2a. All right. And next, what if I want the y-intercept, this spot? The y-intercept is where what? You set x equal to 0, good. And on this spot, these are the x-intercepts, so you set y equal to 0. And it's also the quadratic formula solves those, or factoring. All right, there you got a little notes sheet that tells you everything about quadratics. All right. So then what if your quadratic is mixed into an absolute value and then set less than 0? What? All right, so let's do where these get more complicated. So the next step up is, what if I just give you a quadratic that doesn't have an ending? And then I say absolute value of that. Do you remember what that does to the graph? Makes the y values positive. True. When you do the outside, that's like if it had been like this, it would make it bounce up like that. I'll go to the back because I can tell I'm blocking some people. All right, so let's investigate further. Let's say, can you slide up about 6 inches? A little bit further. Everybody in this row, slide up. Middle row, slide up. Can't get round back and come on, slide up. You knew this. All right, there we go. Thank you very much. All right, so putting absolute values around it, and I'm setting it greater than 0. Now I'm going to erase the y equals, and there's your problem. Imagine that's on the test. So just out loud, some of the things you'd be thinking. If you can use a calculator, what could you do? I could graph it. And let's say that it ends up looking something like this. Where would that be greater than 0? Think about it. Don't absolute values have to come out bigger than 0? It'll always be above 0. So what's the answer? All real numbers. That would always be above 0. Okay, now let's change it a little bit. Let's say that the problem doesn't say just greater than 0. Well, let's just make a simple little tweak. Let's make it greater than or equal to 0. So we know that greater than is going to be easy. It's pretty much all the time. When is it greater than or equal to 0? It's still all the time. Because why? Well, it's just now it can be 0 or above 0, and that's what it always was before. Okay, and then how about less than or equal to 0? That one, there's only a couple times when it is less than or equal to 0. So obviously we must have to find these spots somehow. So now we're going to go to the algebra. I always think it's smart in this unit to make a little sketch of it to see kind of what's going on, and then we do the algebra. X squared plus 6x has to be less than or equal to 0. And what's the other equation? X squared plus 6x has to be greater than or equal to 0. Why do we have to switch the sign? Because we were going to make this negative 0, but negative 0 just is equal to 0 again. So that's why you have to switch the sign. All right, now I'm going to solve this. And I can see from looking at my little picture here that there should be 2 answers at most. Is it possible I'm going to come up with 2 answers here and 2 answers there, making a total of 4 answers? Well, I could come up with 4 answers. This is that unit where you got to figure out which ones work and which ones don't. All right, so next, if you can factor it, you should. So we take this and factor it. A lot of people can factor the normal ones, but they get stuck on the ones like this. What factors out of both parts? X. So this is x, and x plus 6 is less than or equal to 0. So what are the 2 key spots, obviously? 0 and negative 6. Okay, so now, turns out my sketch was off a little bit, but it wasn't too far off. This was over a little bit. So it turns out it hits at 0, and it hits at, oh, negative 6. Again, the whole thing should have been shifted left or something, so.
Wouldn't it be like
Question about the roots.
wouldn't it be like this?
It would have to hit here and here.
Like the parabola though, wouldn't it be like this, not like this, because it doesn't have a negative right there?
You are correct that there's no negative in front, so it would be like this. But the absolute value around the outside of it, remember that, is going to cause the graph to look different. But for right now, all we were trying to do is solve what are the 2 roots. And they were 0 and negative 6. You with me so far? Okay, so now we're going to go to the other one. I'm going to solve this one. Well, it's the same thing, except bigger than 0. So apparently, it's all about 0 and negative 6. Here's negative 6. Here's 0. So the way I would approach it now is, these are zeros. So they work. Why? Because it says or equal to in the sign. And now I just have to decide if I shade on the inside or if I shade on the outside. This tells me less than, and it feels like I should maybe shade to the left of these things, but to the left of what? So this tells me greater than, so I'm feeling like I really don't know where to shade. So what you do, you test points. What's a good point that's between 0 and negative 6? Something simple.
-1.
I agree, -1 or -2, either one would work. Would you please take a moment and stick that in the equation and see if it works? If I put in -1 in this equation, I'm going to get 1 plus -6, which makes -5. Is -5 bigger than or equal to 0? No, that didn't work. Does it work in this equation, though? -1, -1. Well, yeah, of course, it's going to come out to -5, and is -5 less than or equal to 0? Yeah, it works. So did it work in here? Yeah, it worked in there. Does it have to work in both equations? No, does not have to work in both equations. What it really should do is work in the original equation. Do you get how a kid could do that? I got to really check the original equation, which is up here. That's the one that'll tell me whether it really works or not. Okay, now I come out with my -5. It's absolute valued, which makes it +5. Is +5 less than or equal to 0? No, this did not work. So when I got it working in one and not working in another one, I knew something weird was going on. And then I'm like, okay, that's because we didn't check it in the original one. That's where you should check them. Okay, now we should check a number a little bit bigger than 0, like maybe 1. If this was +1 and +1, then it would be 1 squared plus 6, which would be 7. Is 7 less than or equal to 0? Wait a minute. Weren't we doing less than or equal to 0 right now? Pretty sure. The original problem? All right. So then I'm going to say 7 is less than or equal to 0. Nope, doesn't work. And then last but not least, I would check -7. Negative 7 when put in gives me positive 49 and negative 42, which is like positive 7. Is positive 7 less than or equal to 0? Nope. How could it not work anywhere? That's a false reading of this answer. I didn't say it didn't work anywhere. It only worked at these two spots. Now remember what it really looks like. I'm going to graph it for you again. What does this really look like? I'm going to grab one of these guys, drag it over here, make it bigger. Where are the two spots it touched at?
0 and -6.
0 and -6. Do you remember how this was going to be a U shape, but wait, we absolute valued it. And it bounced up. That's what it really looks like. And the question was, when is this going to be less than or equal to 0? The only times it'll work are when it's equal to 0. So that meant these were the only spots that would work. That means it doesn't work in here or in here or in here. It only works in those two spots. And so the answers are x equals 0 and x equals -6. Okay. I hope you're seeing how this is a blend of graphing and also using algebra to find the zeros. Let's do another one. No absolute value this time. Just solve. X squared minus 3x is less than 4. You need to be so good at your basics, like, oh yeah, always set it equal to 0, of course. Check to see if it factors. Doesn't factor, quadratic formula. If I need the vertex, negative b over 2a. Want me to find the x-intercepts? I'll set y equal to 0. Want me to find the y-intercepts? I'll set x equal to 0. I want to make a picture of it? I can. Tried to make this one factor. Did it factor? Excellent. X minus 4, x plus 1. I'm feeling like I got roots here at -1 and +4. And it's a parabola that goes like that. And that yet I want it to be less than 0. When is my parabola less than 0? Well, kind of right in this little zone here. How do you say that? This is -1 and this is 4, so you'd say it's from -1 to 4. And brackets or not?
Not.
Why not, sir?
Because it's not less than or equal to 0.
Yeah, there's no equal to sign here. -1, when you actually put it in, would come out equal to. And I don't want it to be equal to, I want it to be less than 0. So that doesn't work, so I put parentheses, and therefore it's -1 to 4. Raise your hand if you add -1 to 4. Okay. If you didn't, I hope you know where your mistake is. And if you don't raise your hand moments like that, it hurts me, because not like I care that, oh, you know, like I'm mad at you for not raising your hand. It's more just like if half the class doesn't raise their hand because they're being lazy, it makes me think, ooh, only half the kids knew how to do it. And it makes it harder for me to judge whether I should go on or not. So please, when I do ask, did you get it or not, just take a quick, put a hand up quick if you got it. And if you didn't, definitely don't fake it, because I think I'm going to do one more, because I think we're not quite there yet. But I can't quite tell when people don't raise their hand. All right, try this one. X squared minus x minus 2 is greater than 0. I'd also like you to sketch it. At least try to factor it. You got an x and you got an x, and one has to be negative, one has to be positive, and I have a 2 and a 1, and I put a 2 here and a 1 here, and I check it, see if it worked. X squared plus 1x minus 2x makes negative 1x. Looks like it's going to work, and it did work. So that I have two answers, 2 and negative 1. If I graph it, I have a 2 and a negative 1, and then I know it's a U shape. And where does the parabola greater than 0? Ooh, it's greater than 0 on the outside edges. Like in this little zone, and then this little zone is where the parabola is bigger than 0. So then I got to know what those 2 points are. Of course, I already know them. They are negative 1 and 2. And so I'm going to write my answer as negative infinity until it hits 2. Union with negative 1 to infinity. Watch close on whether there's brackets or not. In this case, are the... Oh, looks like there's a mistake. Yes?
Yeah.
You raised your hand?
Oh, because -1 and 2.
Oh, I got the numbers reversed. Sorry. You're right. Negative 1 and 2. Thank you. I'll write this over here. Negative infinity to negative 1. Union with 2 to infinity. There. Okay. The hardest kind of all is where you mix absolute values and parabolas in the same problem. But I'd like you to just think of this as, like, this is a parabola that's been shifted up 1. And it meets a absolute value that has been shifted left 3. And they say, hey, I wonder when the parabola is bigger than or equal to the absolute value. Now, this is going to be tricky because it's got both absolute value and parabolas. Parabolas need to be solved using factoring of the quadratic formula, and the absolute value needs to be solved using splitting it up into 2 parts. And yeah, this is as gross as it's going to get. So the first thing I recommend, sketch it. You all know how to make a parabola that's been shifted up a little bit. You all know how to make a V shape that's been shifted left a little bit. And then you can at least know how many answers there's going to be. Parabola shifted up 1. V shape, absolute value, shifted left 3. Could you be convinced that depending on how steep this is, there might be an intersection point, or maybe if the parabola goes a lot wider than I'm drawing it, that it won't actually touch? Or do you think it for sure touches? All right. Feeling like is it for obviously it touches here. The only question is whether or not that's going to have 2 answers or just 1. There can be scenarios where it'll miss it, and I'm picturing though that yeah, this is I'm now on the for sure it's going to hit twice team. Okay. Now I can do it with algebra, or on this test, you're allowed to use calculators. So I'm going to want to take a moment right now and talk you through how you could use the calculator to good effect on this type of question. So grab your graphing calculator. I'm going to pause for a second while you pull up your graphing calc. So this is the part where you're going to graph y equals x squared plus 1. You know what that's going to look like. It's a parabola shifted up 1. And then you're going to write, how do you type in absolute value on the calculator? You use the master button. What's the button that tells every function's location on the calculator? In case you didn't know this, it's right above the 0. See that thing says catalog? Go to catalog and it says ABS. And it has a beginning parentheses. So that would have you type in ABS parentheses x plus 3 end parentheses. That's how you'd type in absolute value of x plus 3. So now get those two graphed. And then if you can't see where they touch, try zooming out far enough so that you can see where they touch. From here, it's just about using the window and going, okay, I think I need to move up more, or I need to be able to see more to the right. And so you'd make your x's go to bigger numbers. Play with the window until you can see a picture. And can anybody already verify on the graph of these two? Y equals this is ABS x plus 3, and y equals x squared plus 1. Do they touch twice? Okay. And then how do you find those spots where they are touching? Second calculate intersect. The second key, and it's right above trace, is where the calculate is. Second calculate, and then when given those choices, second calculate intersect. Then you arrow right on top of the spot you want it to intersect, and you hit enter, enter, enter. All right, I'm going to pause for a second because usually there's some tech issues at this point. Raise your hand if your calculator's stuck in a weird mode and you want me to fix it. Okay. And after you're done second, calculate intersect, there's a left one and a right one. I know that my graph is not looking exactly like yours, but what did you get for the, which one are you on, left or the right?
I believe.
Okay, which one are you on right this second?
Left.
On the left one, what is that x equal to?
-1.
-1. And how about the other one?
2. The second x.
The x of negative,
First x is -1 on the left side.
but -2 doesn't make sense over there.
Or I mean, 2.
Probably is +2.
This way.
Can anybody verify the other one's +2?
Yeah.
All right, so we got -1 and +2. These are the x values. Remember, if I follow it down to the x-axis, where it was -1 and +2. Yay! Now, you just got it wrong. Because -1 and +2 are part of the answer, but you should make a number line and go, so do I go between them? Is it equal to them? Is it between them? Is it like outside of them? So it's a great start to have the roots, but you aren't done yet. This is what brings this up to honors pre-calc level, because you've graphed things and saw where they crossed before. So how could you tell? Let's say that you had no other like clues about, which way to shade this thing. Do you remember looking at the graph and just trying to decide which one was above the other one? So look at the graph for a second. We got a U shape and a V shape. I'm going to shade in green where the parabola is bigger than the absolute value. Here's where the parabola's above the absolute value, and then here's the rest of the place where it's above the absolute value. Does it seem to be true in here? No, that's where the absolute value is above the parabola. That'd be backwards of what we wanted. Okay, so final answer is basically you want it to go outwards. That's what I think. Would it be smart for me to check myself? Oh yes. Check yourself before you wreck yourself in the test. Because I'm telling you, the number one mistake on this test will be kids will shade the wrong way. They think they've got it and it's like, oh, I got my two roots and I shade between them. I almost never have to mark the roots wrong. You guys get pretty good at finding where they cross. You might be doing it with factoring, you might be using quadratic formula, but kids usually find the roots. But they're notoriously bad at shading in the wrong spot. So I'm going to check the point 0, which is between -1 and 2. And I'll make sure 0 doesn't work. So I'm going to go put 0 in right here in my original. Is 1 bigger than the absolute value of 3? No, that did not work. So that's good. So far I'm right. I'm going to check 3. if I put in 3 in the original, is 10 bigger than 9? Yes, it is, so that seemed to work. I've double checked it. And how about the negative 2 that I would now check? Putting in negative 2, negative 2. Then this one's going to be 4 plus 1 is 5, is greater than or equal to 5.
And then negative 2 plus 3.
Oh, wait a minute. My bad. Negative 2 squared is 4, plus 3 is 7, not 5. Thank you. Is 5 greater than 7?
Wait, what?
What?
Negative 2 plus 3.
Okay. It's got so messy I can't read my own writing, and I apologize for that. I'm going to try to fix it. I'm going to put the 2 back in, and you're right, that is a 2 being in there. It's not a 2 squared. It's just a 2. 2 plus 3 is 5. So I'm back to 5.
That's negative.
Oh, negative 2. Negative 2. I had a negative on this one. All right. Dang. Okay, so 3 plus negative 2 is 1. 5 is greater than or equal to 1. Now, that's a little dose of my own medicine because I told you that kids are really bad at trying to figure out where to shade. And that's exactly what would have happened right there. Is all it takes is put in one little number slightly wrong and all of a sudden, oh, looks like it doesn't work. I'm not going to shade there. So, I will tell you this. It's almost always either inside or both of the outsides. So it'd be really weird if it was only one of the two directions. So since it worked on the right, I would have probably kept checking myself until I figured out what was going on. If it was shading here and not shading there, that would have been weird. It usually shades on the inside or the outside. Okay. Yay. Now, is there anything else on the test that we have to know? Yes, but this isn't a full review day. I will do a lot more review when we come up on the test. Yes.
So for your final answer, do you want the shaded to be on the graph or on the number line? Or does it matter?
Well, our answer is this part and this part. So I could either say it on a number line, because number line is an accepted form. And I would go like this, from 2 to, here's negative 1. And it worked because it says or equal to. I got to fill it in there. And then I shaded left. There, that would be an okay, wait, nope, negative 1. There we go. That would be an okay way to say it. Or B, I could say negative infinity to negative 1, bracket, 2 to infinity, bracket. Does that answer your question? Okay. Okay, some intense stuff. 12-minute warning is going off, so it's about time to get into the homework. Everybody find the homework. I'm going to pause for a second as I try to explain verbally which problems we're doing and not doing. Okay, so I'm recording again. The assignment is going to be from 5.4, day 2. The first page of problems, there's 4 questions. Those are all kind of the normal, important to know how to do problems. And then I'm going to have you just do 2 more problems on the next page. So first, the whole first page, which was kind of greenish color, you're going to do that whole page. Then could you scroll up so I can see it? Because I can't see it on my iPad right now. I mean, like further down. There we go. And then zoom in on that one. And then on this one, we're going to do the first 2. 33 and 35. Now I will warn you, the ones that are R3s on our test are usually more like that. They're usually more like a word problem. Okay, so the first whole page,
This is the third.
and on the second page, oh wait.
This is the third page. This is the next page.
Oh,
This is,
man.
and there's this.
The whole first page.
Okay, we need to go to the first page.
Okay, yeah, first page.
Okay, the one that says assignment day 2, and it has problems 17, 21, 25, and 30. Those, you do all of them. All right, those are the kind of like the main bread and butter base skills. And then on the next page, you're doing the first 2 word problems. The first one says the profit in dollars made by selling. And the second one says the temperature T in degrees Fahrenheit. Those are the ones you should do. And you can skip the rest. Okay? All right. Then tomorrow, you will need your graphing calculators more than normal. Make sure you have one, because we're going to be doing some stuff with something called a linear regression. That's all I got for you for today.